Welcome to my presentation. In this presentation, let us look at an example of vector triple products. So in here, let us take an example. And in this example, if we have vector A as 3i minus j plus 2k, and if we have vector B as 2i plus j minus k, and if we have vector C as I minus 2j plus 2k, then we want to prove one of the properties of a vector triple products. We want to show that vector A cross vector B cross C plus vector B cross vector C cross A plus vector C cross vector A cross B. When we add up all of these, that value should be equal to 0. Okay, so we'll take one at a time and then we'll see how we can prove this. So for simplicity's sake, I'm going to call this expression as x, this expression as y, and this expression as z. So we'll see what these values are. Okay, so let's get started. We'll first solve the first part of it. We will solve vector A cross B cross C, and we're going to, when we solve this, we'll see what we get. In here, the way to do that is we're going to take vector A and we want to cross that by the product of vector B cross vector C, right? So the way to do that is we're going to use determinants to simplify that. So we have I, J, K, and for vector B, the components are 2i plus j minus k, and therefore we'll write the coefficients of I, j, and k. The coefficients of I are 2, the coefficient of j is 1, the coefficient of k is negative 1. For C, the coefficient of I is 1, the coefficient of j is negative 2, and the coefficient of k is 2, like that. So when we expand this, this is going to come out as follows. We're going to expand along the first row, and we're going to use this sign convention, positive, negative, positive. When we do that, it's going to be I, the minor of that, which is going to be 1, negative 1, negative 2, 2, minus j, the minor of that, which is 2, negative 1, 1, and 2, and then plus k, the minor of that, which is going to be 2, 1, 1, negative 2. When we expand this, this is going to be I, the minor, the simplified form would be, the simplified form here is going to be okay, 1 times 2 is 2, and then negative 2 times negative 1 is positive 2, with the negative sign will be negative 2, and therefore minus j times 2 is 4, 1 times negative 1 is negative 1, times negative will be positive 1, plus k times 2 times negative 2 is negative 4, 1 times 1 is negative 1. So therefore this is 0, and this one here is going to be 0i, 4 plus 1 is 5, negative 5j, and then negative 4 plus negative 1 is negative 5, negative 5k. So we got that, and now we want to cross this by vector A. So vector A is this, isn't it? 3i minus j plus 2k. Here again, since we are doing the cross product between two vectors, we can use determinants again, and therefore the way to do that is as follows. I'm going to write this as I, j, and k. The coefficient of I is 3, the coefficient of j is -1, and the coefficient of k is 2. And for the second vector, the coefficient of I is 0, the coefficient of j is -5, and the coefficient of k is -5. So if we want to find the determinant of that, and we're going to travel along the first row, and the sign convention we're going to use is positive, negative, positive. And when we expand this using minors, it is going to be as follows. I, the minor of that is -1, 2, -5, and -5, like that, minus j, the minor of that, 3, 2, 0, -5, and then plus k, the minor of that, 3, -1, 0, -5. So when we expand this, it is going to be I, -1 times -5 is +5, minus -5 times 2 is -10 times negative will be +10, minus j times 3 times -5 is -15, 0 times 2 is 0, plus k times 3 times -5 is -15, minus 0 times 1 is 0. So therefore 5 plus 10 is 15i plus 15j minus 15k. So this is what we've arrived at. So this is a result of vector A cross vector B cross C, like that. So I'm going to put a box around this, indicating that that is the first part of the first part of the property. The second part of the property is telling us that we're going to take B cross C cross A. Okay, so we're going to first find the cross product between C and A, and then we'll find the cross product with B. So to do that, we're going to follow this process. Vector B cross, and then we can find the cross product between C and A by using determinants. So I, j, and k. The coefficients, the vector C, for vector C, the components we have are I, -2j, and plus 2k, and therefore the coefficient of I is 1, the coefficient of j is -2, the coefficient of k, let me write this a little better, this is -2, and the coefficient of k is +2, right? And for vector A, the coefficient of I is 3, the coefficient of j is -1, and the coefficient of k is +2. So we're going to expand this. When we expand this, we're going to expand along the first row, and the sign convention we're going to use is positive, negative, positive. When we expand it this way, we're going to get I, the minor of that, which is -2, 2, -1, 2, and then minus j, the minor of that, which is 1, 2, 3, 2, and then plus k, the minor of that, which is 1, -2, 3, -1, like that. Therefore, when we expand this, we're going to get I times -2 times -2, -2 times 2 will be -4, and then -1 times 2 will be -2, plus that will be +2 because times negative, minus j times 1 times 2 is 2, minus 3 times 2 is 6, plus k times 1 times -1 is -1, and then 3 minus 3 times 2 is negative 2 is negative 6, times negative will be positive 6. So when we expand this, this is going to be, let me write it this way. Negative 4 plus 2 is negative 2i. 2 minus 6 is negative 4. Negative 4 times negative j is positive 4j. Negative 1 plus 6 is positive 5. Therefore, plus 5k. And we're going to take this, and then we're going to find the cross product with b, which is 2i plus j minus k. So to find the cross product between b and the product of c cross a is in there. Therefore, we're going to use determinants once again to find the value of this. So the way we can write it is as follows: I, j, and k. The coefficient of I is 2, the coefficient of j is 1, the coefficient of k is negative 1. For the second part, the coefficient of I is negative 2, the coefficient of j is 4, and the coefficient of k is 5. We'll want to find the determinant of this. We're going to travel along the first row. The sign convention we're going to use is positive, negative, positive. When we expand this, we're going to get I, the minor of that, which is going to be 1, negative 1, 4, 5, right? And then minus j, the minor of that is 2, negative 1, negative 2, 5, and then plus k times the minor of that, that is 2, 1, negative 2, and 4. So therefore, when we expand this, it is going to be I, 1 times 5 is 5, minus 4 times 1 is negative 4, times negative will be positive 4, minus j times 5, 2 times 5 is 10, minus negative 2 times negative 1 is positive 2 with a negative sign. Therefore, and then plus k times 2 times 4 is 8, minus negative 2 times 1 is negative 2, times negative will be positive 2. Therefore, we can write this as 5 plus 4 is 9i, 10 minus 2 is 8, so therefore plus, or this is going to be minus, this is going to be minus 8j, and then 8 plus 2 is 10, therefore 10k, therefore 10k. So this is a product of vector b cross vector c cross vector a. I'm going to put a block around this as well. We want to use all of this information and then see if the sum of all these will be equal to 0. So let us look at the third part of the expression. The third part of the expression is telling us that if we have vector c, and if we were to cross that by the product of vector a cross vector b, and we'll see how that comes out. So therefore, the way we can write this one is as follows. We'll keep the vector c like that for a little bit and simplify a cross b. We want to use determinants to simplify this, so therefore we're going to use I, j, and k, and then we're going to write the coefficients of I, j, and k for vectors a and b here. So for vector a we have 3, vector j is negative 1, vector k is 2. For b, the coefficient of I is 2, the coefficient of j is 1, the coefficient of k is negative 1. So if we were to expand this, if we were to expand along the first row, the sign convention we're going to use is positive, negative, positive. And when we expand this, it's going to look like this. I, the minor of that is negative 1, 2, 1, negative 1, minus j, the minor of that is 3, 2, 2, negative 1, and then plus k, the minor of that will be 3, negative 1, 2, 1. Now we can expand this, and this is going to be I times negative 1 times negative 1 is positive 1, minus 1 times 2 is 2, minus j times 3 times negative 1 is negative 3, minus 2 times 2 is 4, plus k times 3 times 1 is 3, minus 2 times negative 1 is negative 2, times negative will be positive 2. Therefore, we can simplify this as follows, isn't it? So this is going to be 1 minus 2, it will be negative 1. Therefore this is going to be this is going to be negative I, right? And then negative 3 plus negative 4 will be negative 7. Negative 7 times negative j will be positive 7j. And then here we have 3 plus 2 is 5k. We take this and we're going to perform the cross product with vector c, and vector c now is I minus 2j plus 2k. Okay, so therefore this time again, since we are doing the cross product between these two vectors, we can use determinants, and the way to do that is as follows: I, j, k. The coefficient of I is 1, the coefficient of j is negative 2, the coefficient of k is positive 2, the coefficient of I is negative 1, the coefficient of j is 7, the coefficient of k is 5, and if you find the determinant of this, we should be able to get a value. And then the way to do that is we're going to travel along the first row. The sign convention we're going to use is positive, negative, positive. Therefore, when we expand this, this is what we're going to come up with. I, the minor of that, let me write that. I, the minor of that, which is going to be negative 2, 2, 7, and 5, minus j, the minor of that, which is 1, 2, negative 1, and 5, and then plus k, the minor of that, 1, negative 2, negative 1, and 7. Okay, so when we expand this, we're going to get I, negative 2 times 5 is negative 10, minus 7 times 2 is 14. So we got that. Minus j times 1 times 5 is 5, minus negative 1 times 2 is negative 2, times negative will be positive 2, plus k times 1 times 7 is 7, minus 1 times negative 2 is negative 2, 1 times negative 1 times negative 2 is positive 2, minus 2. So therefore that is what we have. So when we simplify this, this is going to be negative 10 plus negative 14, that is going to be equal to negative 24i. 5 plus 2 is 7, therefore minus 7j. 7 minus 2 is 5, therefore plus 5k. And this is the result of vector c cross vector a cross vector b. This is what we got. So let me put a box around this. And now, since we have all the values, let us combine all of these and see what we get. So when the first part of the equation was 15i plus 15j minus 15k, and that is coming in from yeah, let me go back here. Yeah, that is the first part of the expression. The second part of the expression was plus 9i minus 8j plus 10k, and the third part of the expression was minus 24i minus 7j plus 5k. So when we simplify all of this, we can see that we will see what is going to happen. So in here, let me get another color. So 15i plus 9i is going to be equal to plus 24i, and we have a minus 24i. So therefore, these cancel out. 15j minus 8j minus 7j. So 15j minus 8j minus 7j, those cancel out. Then we have negative 15k plus 10k, which is negative 5k, and then we have a positive 5k here. Those cancel out, leaving us with 0. Therefore, this property is true. When we do this, I'm going to write this property here. A vector A cross B cross C plus vector B cross vector C cross A plus vector C cross vector A cross vector B. When we add up all of these, that value is equal to 0, and that is exactly what we got, and that is what we got. So by using the vector triple product, we were able to prove that when we add up all these parts of the expression, the value is going to go to 0, and that is one of the properties. In my next presentation, we shall look at some more examples related to vector triple products.